Alright, just before we start routing, I'm going to make sure all our alignments are perfect. So I'm going to do dimension. I'm going to choose the measures layer, 47. And I'm going to make sure that this is indeed 40 millimeter, which is what we want, and this is 33. Probably should have done this earlier. It would have caught that I didn't mean to make it 30. Change this back to top. And now we're going to start routing. I'm going to start routing with the power because they're all kind of contained, and then do the other wires respectively. So let's go ahead and do that. But first we'll do a polygon, and this is going to be our ground. Draw all the way around the top layer. Good, call it ground. If we do rats, it connects our ground, so that's good. And then I'm going to copy it and then paste it right on top of it. Do info and select one of the two top polygons to be on the bottom, and then do rats, and then we can see that there is some blue on the bottom, so that's connecting our grounds on the bottom as well. So now we hit all the grounds. There wasn't actually that many on this board, but that's going to help clear a couple air wires. So let's route power. I want to route 20 mil on the top, connect the switch to the battery, connect the other end of the switch, or technically our 9 volts, into here, and connect it here into the VN pin. This pin is the shutdown pin. It doesn't need to be a thick wire, so we're going to route 6 mil. It's going to have a very low current, so that's why we don't need anything thick there. And then let's continue with our high power lines. 20 mils into the capacitor. And then let's connect our 3.3 volts to this capacitor. And then from here into our microcontroller. Probably doesn't have to be 20 mil, but that's fine. And then I'm going to route 10 mil to our real-time clock. So something like this is fine. It's not going to consume a lot of power, so we can make it a little bit thinner. We can connect it to the capacitor. I'm actually going to connect it above it because I want that capacitor dedicated to just doing its work on the ATtiny. It will actually affect this too, which is also great. And then we're going to add a couple ground vias. So you can do via ground. I want them to be 10 mil because that's the minimum we can do for Oshpark. And normally I like to place them right around here, but can't fit it there, it'll be in the wire. So here's a good alternative. Similarly for this one, I could put it in the spot I want. And then for this guy, I like to put one here. And in most regulators, if you're pulling a lot of power, you're going to want more thermal vias. This one's not going to pull a lot of power, but I'll just take the precaution of adding some vias there. Rats. Got all those, so that leaves just our connections with the real-time clock, ATtiny, and then our resistors. Let's go ahead and do the SDA and SCL of the real-time clock. So I'm going to route 6 mil, kind of thread it right through here. And then for SCL, it's a little more out of the way. So let's go like this. Here we are. So now we have the real-time clock all connected. And let's go ahead and do the easy routes here and just connect our resistors to the connector. Great. And that leaves us just connecting the resistors to the ATtiny, and this one will actually take a little bit of work and a little bit of careful massaging and fine tuning to get everything to fit and for it to of course look nice. So let's go ahead and start connecting our ATtiny to our resistors. So let's start with the easy one here where it's almost a straight shot to this pin. We'll go along here a little bit. Actually, we'll start from this side. That'll make it align a little bit easier. Connect to this pin, and then this one we can't make a straight shot, so we'll go around like this. And that's going to be a common theme with routing these pins, is they're all kind of going to go around like that. Alright, so now we have these other ones, and if you see, if we try and route on the top, we're going to have some trouble. We're going to have to thread through here if we do that, but also we have all these other ones that are going to go through too, and we can't fit 2 wires between any of these pins, and our clock's already kind of in the way. So we're just going to take the easy route and just route them on the bottom and kind of do that wrapping similarly here, except on the bottom layer. So let's go ahead and start with the further pin. Careful, we have the via here. It's okay if we go under the red wires. They're all orthogonal to each other or skew. Alright, and this guy's going way over here. Great. And let's just do that with all the other pins. Alright, so we have all our resistors connected. We can do rat's nest and see what our board looks like from the top. Great. We can do DRC, check to see if we have any errors. We have no errors on the bottom left. If you do, just go ahead and fix them. And we're technically done, but we still got to add some of our swag onto here.